In this very lesson, we shall be looking at another approach that can be used to find the inverse of a matrix. And we are looking at what? The 2 by 2 matrix. If you could recall from our previous studies on multiplication of matrices, we said that multiplication of matrices is not commutative. So when you have any two matrices, let's say matrix A and matrix B, then the product of AB is not equal to the product of what? BA. This is what we said in our previous lesson on multiplication of what? Matrices. But when you realize that the product of A and then B is giving you the product of BA or is the same as the product of BA, then we can say that one of these matrices is the inverse of the other. So you can say that A is the inverse of B or B is the inverse of A. So let's say that A is the inverse of B, A is the inverse of B, and if that is the case, then B is the same as what? A. So we are going to have A times what? A inverse. Now anytime you multiply a matrix by its inverse, it gives you what we call the unit matrix or the identity matrix. So this is the second approach or method that is going to aid us to find the inverse of a matrix. So we have our first example. We are going to look at it. So we have matrix A with these entries, and then we want to find the inverse of matrix A. So we are saying that a matrix times its inverse gives us what? The unit matrix. So we have a matrix times its inverse gives us what? The unit matrix. And we know that the unit matrix, the entries are 1, 0, 0, 1. Now we don't know the inverse of the matrix, so we are going to let the entries A, B, C, and then D to represent the inverse of matrix A. So we are going to have matrix A, we have, and then the inverse. We are using these variables to represent the inverse of matrix A. And the whole of this is equal to what? The unit matrix. So once we have this, we are going to expand the bracket. So we are going to use the first rule to multiply what? All the entries in the first column. So we have 2 times A will give us what? 2A plus 1 times C will give us what? C. Let's move on to the next column of the second matrix. 2 times B will give us what? 2B plus 1 times B will give us what? D. Then we move on to the second row of the first matrix. 9 times A will give us what? 9A plus 18 times C will give us what? 18C. Then we move on to this. 9 times B will give us what? 9B plus 18 times B will give us what? 18D. And this is equal to 1, 0, 0, 1. So once we have this, we are going to apply the concept of equality of matrices. So we are going to what? Equate the corresponding entry. So it means that this corresponds to 1. So we have 2A plus C is equal to what? 1. We can see that this also corresponds to 0. So we have 2B plus D is equal to 0. This also corresponds to that. So we have 9A plus 18C is equal to 0. And then this also corresponds to 1. So we have 9B plus 18D is equal to 1. So let's call this equation 1, equation 2, equation 3, and then equation 4. Now looking at the variables, we have AC and then AC. So we can pick equation 1 and then equation 3 and then we solve it simultaneously. Then we come and pick equation 4 and then equation 2. We solve it simultaneously. So we have now when you solve these two equations simultaneously to find the value for A and C using your calculator, you have your A to be equal to 2/3, and then you have your C to be equal to -1 all over 3. You can use your calculator to find A and then C. You can also use your calculator to find the variables B and D. And when you do that, you have your B to be equal to -1/27, and then you have your D to be equal to what? 2/27. So these are the values for these variables. And earlier we said that we are letting the variables A, B, C, and then D to represent the inverse of matrix A. So we are just going to substitute these values in place of these variables. So we have A to be what? 2/3. We have our B to be -1/27. We have our C to be -1/3. And then we have our D to be what? 2/27. And this is the inverse of matrix A. As easy as that. This brings us to the end of today's lesson. See you tomorrow. Bye bye.